Good morning, everyone. It's always a pleasure to come back to the 3D Experience Forum in North America. As Dean just said, hardware and software coming together can be at times frustrating. And as a result of that, creating connected experience can become, for a lot of companies, for a lot of you in this room, an interesting challenge. So we have been working with many of you for the last 5-6 years on tackling this issue specifically, and I would like to share some perspective with you in the next few minutes. When we think about consumer experiences at Da쏘sistems, you know us for being the 3D company. For the next few minutes, I would like to twist that a little bit and have you know us for being the 3C company. Because when you design a connected experience, you have to think along the lines of these 3 key buckets that you see on the screens. These pictures are actually the pictures of customers of Da쏘sistems. The first one is Hello, who creates this smart IoT connected device that you can install at home to monitor a bunch of key features and functions and make sure that you keep your home under control. This device is full of electronics, sensors, actuators, and is constantly on, connected to the network. The second picture is a picture of Ericsson. Ericsson is one of the largest, if not the largest, telecommunication equipment manufacturer in the world. And all of you in this room are actually contextually positioned on a network. Somewhere out there are a bunch of cell towers, a bunch of equipment that are monitoring continuously what's going on and making sure that your device has a right to access the network, that everything has been provisioned, paid for, and that the network is constantly software-defined and rebalanced, reconfigured to ensure the quality of service that you expect. The third one is Tesla, who is also a customer of Da쏘sistems, as many of you know. And one recent example in the news that was a terrible event that just hit Florida when the storm hit. The guys from Tesla did something absolutely extraordinary. A few days before the storm came, you have probably seen that in the news, they did what we call a SOTA, firmware over the air, software over the air upgrade, to the Tesla cars that were in this part of the US to make sure that the car will be optimized for battery life and that the range of the car will be extended temporarily. And this is an example of a continuously updated and upgraded experience made possible today thanks to software. So these 3 examples show how software can be used these days. And this is also why software has become a big topic for many of you in this room and all around the world. What you see on the left side is a number of lines of codes that are produced today, that are embedded today in software that powers the work and the life that we have on a daily basis. You see that roughly every 7 years, the number of lines of codes is multiplied by 10, which makes, for many of you in this room, interesting days to define, test, prototype, validate, test again, debug all of these lines of codes. Luckily, this code is not floating in the air alone. It powers hardware and software and other devices, which makes the challenge even more daunting. This is why many of you in this room have invested massively in hiring developers, testers, software engineers to tackle this challenge. And what you see here is actually the ratio of software versus hardware engineers that you can find on a job site like computercareer.org. If you go out there, you will see that you have exactly 13 times more jobs open today in North America on software versus hardware. In many companies, this ratio can go up to 18. So it creates some very interesting challenge on the way you engineer, in the way you coordinate all the disciplines, and how you make everyone get together. Last but not least, I would like to finish with this pie chart extracted from a recent study from Morgan Stanley. When you look at the value of a car today, 90% of the value of the car comes from hardware, 10% comes from software. When you look at the right side, this is a prediction in 7 to 8 years from now. You see that the value of a car will continue to be made of hardware for 40%, software 40%. And what is the remaining gray zone of the 20? This is content. Because once you don't need to drive your car, when your eyes are off the road and your hands are not on the wheel anymore and your mind is free, then you will be able to start to consume a lot of different content, business content or entertainment content. Once again, this is the power of software delivering more and more value in the daily activity that we have. So, now that we share a common baseline on why software matters and why it became huge and a significant challenge for many of you and many of us, then the question becomes, how do you deal with that? At Da쏘si스템, we believe that continuously, constantly, you need to keep in mind these two big dimensions. First, deal on the left side with technological, process, and financial constraints that are related to software management, while keeping an eye on making sure that whatever we do, whatever we work on, we focus day after day on the customer experience. On the right side, you see three big domains that have been structuring the way we think about software and the way we evolved in the last few years, the 3D experience platform. System engineering and system thinking, and I will show that in a few minutes, DevOps and continuous software upgrade and update, and modularization that now expands beyond the remit of hardware and goes also in the domain of software. On the right side, consumers, all of you in this room, all of us, expect top software quality, expect a strict respect of our privacy and security, and also want to enjoy a great user experience. This is why we called it the 3D experience platform, because it's not a marketing gimmick. This is a way of thinking about engineering great experiences. To illustrate that, we are going to take the example of BIMI. BIMI is a product that we have developed. It's a loudspeaker, but it's kind of a special loudspeaker. It's a portable Bluetooth, Wi-Fi connected speaker, like you can find many out there in the market. But this one is also a video projector. So we're going to launch a video and go into the creation of BIMI 2, which is the next generation. So let's launch the video. So this little video projector has a lot of particularities. One of them is that this is a second generation of an existing product, because many of you in this room are evolving existing portfolio. But this one is special because the software component, the software dimension of this product is what creates the value of this product. Why so? Because this is a video projector and you have embedded software, because you have an application software, a remote that will take control of the device, and you have also a bunch of cloud services. All of that is software related. So here, as a product manager, I'm inventing the next generation of BIMI, BIMI 2. And to do so, I connect to the 3D experience platform, and right there, right now, I find all the information that I need to have to know what's going on. The electronics information coming from ECAD and EDA software, because the platform, the 3D experience platform, is open and connected to this world too. You see the CAD information on the top right corner, and you start to have access very quickly to all the project information to make sure that all the disciplines, all the jobs, and the roles who are working with each other can collaboratively work and deliver this BIMI 2 as quickly as possible. And here we see that the team, who is working in a Kanban collaborative task environment in the platform, in Enovia, has identified that in BIMI 1, in the previous version, there was a problem of image quality. So they decide, in one of their agile sprint sessions, to investigate that and dig a little bit deeper to understand what's going on. So very quickly, the team, who can meet physically, as you see here, or remotely, because all of that is available in the cloud, is going to spot this problem and start to understand exactly what's going on and why and how we need to fix that. Immediately, an engineer is going to analyze across terabytes of information, customer call centers, software crash dumps that comes back automatically to the company, information from forums and news groups and websites, And all of this information is going to be analyzed thanks to the 3D Experience platform with one of our software called Exalead, where the engineers are going to spot exactly the root cause of the problem and identify exactly the requirements that they need to address this problem of auto-feature, autofocus, and image quality. So the problem is now handed over to an engineer who is going to start to investigate the problem a little bit deeper and identify that, yes, definitively, we need to implement an autofocus capability, an autofocus function in this new generation of the product. So they start to iterate with each other, and very quickly, a product manager who is managing here the entire portfolio of the company, not just BIMI, but all the products, is going to create a new module for the variants that will allow everyone in the company to create future products and variants of the same product. In this case, the product marketing team decides to include, as we discussed a few seconds ago, a smooth image module that is going to be part of the future product portfolio and architecture of our portfolio. So here, immediately, this capability is going to be reflected in our requirements. Not new requirements. We are using the pre-existing requirements from the previous version, but we are going to very, very quickly update the requirements and immediately convey to the rest of the team what needs to be addressed and what needs to be done. The first people who are going to work on that are systems architects, because we believe that software without model-based system engineering can be a daunting challenge. So here, very quickly, the engineer, the system architect, is going to search across all the features and functions that have been created at some point in the company, the one that corresponds the closest to this topic of autofocus. They found an existing autofocus function that was used in a different product, so there is no need to reinvent the wheel here. We are just reusing and capitalizing on engineering expertise and IP that exist in the company. And very quickly, the system architect is going to embed in this architecture of the product the new function that he wants to implement. At that layer, at that stage, we are defining the function and the logic of the system. And obviously, you can see on the left side the mechanical functions and electronic functions, and on the right side, these software functions. The two functions that we have here are actually an autofocus function that gets managed automatically by the video projector, and another one that gets triggered by the smart application on the smartphone. So as a software engineer works on that, he just checks the software diagram, create the experience that he wants to build, and very quickly can cascade across the entire chain of decisions, the entire system definition that we built before, the function, the logic, and the very specific modifications of the software that we want to do. Why so? Because here, two engineers are going to work in parallel. One might be in India, the other one in California, and both of them are going to edit the code, retrieve it from Git, for example, a repository for software, and from the platform, they will trigger automatically. One will use Visual Studio, for example, a software environment coding space, where they will adjust the problem of precision of the autofocus by doing a change in the software. At the same time, another software engineer is going to do another modification, not in Visual Studio this time, but in Eclipse. And both of them are going to work collaboratively, thanks to the platform, on the same code, store it, commit, as we say in the software environment, commit it to GitHub, which is a repository, and immediately after are going to build automatically with a build software called Jenkins, for example, rebuild this code and make it available. What you see here is actually the coexistence of the 3D Experience platform with software environment where different disciplines are going to work with each other. But more importantly, what you can do in the platform is to validate and test that this code works as planned. You see on the top right corner that the autofocus function, the mechanical aspect of this product, is actually controlled by the software we developed. and we check at the bottom right corner that the autofocus function is not draining the battery. How do we do that? Because all these systems are interconnected with each other, because the platform governs all of these interactions, and we can also extend that to the radio frequency and electromagnetism testing, because one engineer woke up in a meeting and said, you know guys, I think that we have a problem. We have this radar and these LiDAR sensors, which are going to scan continuously the room. Their frequency might interfere with the frequency of the Bluetooth stack. Thanks to CST, the technology that we acquired recently and that is now part of the 3D Experience platform, we can validate also that. So the team gets together and said, okay, now we have something that works as planned. But the beauty is that we want to test and validate the experience. And what you see here is not just CGI images that have been created by marketing or communication department. They're actually generated automatically straight from the platform. And what we do here, we validate with the latest electronics, the latest design, the latest software, the latest system engineering, the end-to-end experience. So for example, we simulate that the picture projected on the screen was blurred. We simulate the fact that when you press the button, you do the automatic adjustment, and you simulate that from the application, you can take control on the system, and the system reacts, and you validate entirely the experience virtually. At that point, nothing has been manufactured. Nothing has been produced. There has been no material involved. All of that has been done end-to-end virtually in the 3D Experience platform that governs mechatronics, software, and system engineering, and simulation information in one place. So this is the power of the 3D Experience platform in action. We continue to invest every single day in making it better and better, and many of you are stimulating us every day also to make it even better and better. Thanks a lot for your attention, and see you around.